Well, I'm really glad that I could be the first to welcome you to JSConf EU. I pretend that all my talks are keynotes, so. You may recognize me probably as the guy with the weird avatar on Twitter who makes stupid jokes and occasionally is an asshole about node security. You may also be wondering, why do you look like this with the crazy beard? Why do you look like a crazed lumberjack? And I actually tweeted about this. I brought my beard trimmer, but I forgot that things are 240 volts in Europe, not 120 volts, and my battery was dead. So I tweeted this. Now, I've realized at this point, probably looking for sympathy on Twitter is not the best idea, but still, my hopes were up, and this is literally the only reply that I got. So before I talk about computers or JavaScript, I want to talk about phones. Actually, I want to talk about phones. So I would like to draw your attention to the phone in your pocket right now. So probably you've got like an iPhone or an Android, but even if you don't have one of those, it's basically a supercomputer, right? This thing in your pocket has more computing power probably than what we use to put a man on the moon. And this supercomputer in your pocket is connected to this global network, right? So I can get on a plane in the United States with my supercomputer in my pocket. I can fly to Germany, and when I land, assuming that I want to pay AT&T through the nose, I can still continue to receive text messages and calls. That's pretty impressive. So I want you to think about, I'm here in Germany. I might go out to a bar with some of you. Maybe we're hanging out. And let's say after a couple drinks, some good conversation, I decide that I want to stay in touch with you. I want to keep talking to you. By the way, this is the image that you get when you Google for having fun in a bar. So if I want to stay in touch with you, what do? I think bizarrely and wonderfully, the thing that I do is I ask you for your phone number. I ask you for this string of unique numbers that identify you to this global communication system, right? Your phone number. And you probably never thought about why we have phone numbers and why these things are still around. And it turns out it's because of the disease measles. Let me explain. I've also gone ahead and translated this disease. This really won't make sense if you are not familiar with what measles is, and I realize it's not a very common English word. Measles is basically a terrible, terrible disease. So you can do a Google image search for having fun in a bar. I would not recommend that you do a Google image search for measles. It's disgusting. So let me explain what measles has to do with phone numbers. So a brief history of the phone number, if you will. So this gentleman is Alexander Graham Bell. So Alexander Graham Bell was the first person in the entire history of the universe to make a phone call. Now, he did not need a phone number because he possessed the only two phones in existence, and these were wired directly together. As you can imagine, this would not scale for very long. So what they invented was a telephone exchange. And that along with the telephone exchange came the job of the phone operator. So if you're sitting at home and you want to call someone, you would pick up your phone and the light would come on down at the exchange, at the central office. And the way that this worked at first was you would ask for the party by name, right? Because it's the central office for a small little town. There weren't actually that many people. But look at this board. There's a lot of freaking plugs to plug in, right? And as the phone system got more and more popular, it became more and more arduous when someone asked for someone by name to figure out where on this board to patch these two cables into. This is the 1870s. There's no computers to help you quickly look this up, right? You have to basically go to a booklet and look up how to patch these things. And what you ended up needing was a team of very experienced and heavily trained operators. So it was actually during a measles epidemic that there was a physician by the name of Dr. Moses Greeley Parker. And he was worried that if there was a measles outbreak, you can see that these phone operators are working in very close proximity to one another, and measles is very contagious. He worried that if there was a measles outbreak, it could totally cripple the telecommunications infrastructure, primitive as it was at that time. So he thought it would be easier if there was a measles outbreak to train replacement phone operators if instead of asking for someone by their name, you simply asked for their number, and the operator could quickly patch these two things together. So I just want to reiterate here. You enter a phone number into your iPhone because someone was afraid of measles in the 1870s. This technology, these decisions that we make can have repercussions long, long after we make them. So despite phone numbers increasing the efficiency of the human operators, the process was still very slow and quite expensive. So for long-distance calls, this is back in even into the 1920s, for long-distance calls, you would need to talk to a different operator at every exchange that your call passed through, because it would basically be different hierarchies of these exchanges. So the average time between you picking up the phone to call someone long distance and actually hearing their voice on the other end was 15 minutes. So you had to be really dedicated to whoever you were going to call to spend 15 minutes essentially on hold, and they didn't have cool jazz music to put on while you're waiting either. So it needed to be a really important call. Now, in the early 1900s, automatic exchanges began to replace human operators. So in theory, we could have replaced the phone number at this time. But the phone system, of course, was extremely widespread, and you couldn't just rip out the infrastructure and replace it wholesale. It just would have been too expensive and too much of a disruption. So we had to gradually transition the infrastructure from these human operators over to this automated system. And of course, it was much easier for the primitive machines at that time to deal with phone numbers, and that's what people were used to. People were used to picking up the phone and entering a phone number. They didn't want to have to learn some new way to use the automated system. They just wanted the old thing to keep working just faster. So if you think about the phone in your pocket today, it bears very little resemblance to a phone set that someone would have used in the 1950s, right? It's got a screen, which they didn't have back then. It's probably a high-definition screen, millions of colors. You can play friggin' movies on it. Take photos with it, and it can travel with you wherever you go. So the underlying infrastructure, the actual implementation details of how we have this insane global telecommunications network is just radically different and radically more complex than a human operator sitting in a booth manually patching two circuits with a cable. And yet, here we are in 2013, and the way that I call you is I punch in a series of numbers on my phone, and this unique numeric identifier was invented when the threat of a measles outbreak was something that you actually had to worry about in your business. Despite all of this, this is still the most popular option for when I want to hold up a little box to my head and hear someone else's voice come out on the other side. In theory, we could have replaced the phone number at any time, but technology, I think there's a lesson to be learned here, which is that technology, unless it's orders of magnitude better than what we have, really needs to interoperate with the last generation. You can't just replace it wholesale, right? 100 years later, more than 100 years, the phone number has evolved, certainly, but it hasn't been replaced. So one way that you might look at this, I think, is to say that the phone number is kind of like the universal UI of our telecommunications system. Wherever I travel in the world, no matter what country, no matter what phone I'm using, I know that if I punch in a series of numbers, I can talk to someone on the other side. I think that's pretty cool. Now, I think there's something else like this that we have that I'd like to draw an analogy to, and that is the URL. So what we consider to be the original web browser was written by Sir Tim Berners-Lee on a NeXT computer in 1990, but even then, the idea of hypertext, these linked documents, was hardly new. In fact, the term hypertext, these linked documents, was coined all the way back in 1963 by the gentleman by the name of Ted Nelson. Are there any AngularJS fans in the audience? Can you raise your hand? Okay, Ted Nelson also coined the term transclusion. I guess you can't win them all. All right, but even in 1963, 50 years ago, this doesn't even begin to do justice to the age, to do justice to the age of this idea. So Ted Nelson's work is an extension of Vannevar Bush's concept of the memex. You may have heard of this. This is the kind of prototypical pre-hypertext system. Actually used, it's a portmanteau of memory and index.
And this is basically it wasn't a real thing. It was a description of a system for organizing all of your documents. So the idea is you could store all of your books, all your other communication, and you could organize and retrieve them radically, but it was pre-electronic, so it used microfiche. But one thing I want to do is take a second to reflect on the fact that all of these things are systems for storing and navigating documents. Sir Tim Berners-Lee's World Wide Web, Nelson's hypertext, Bush's Memex. These are all things for viewing documents. And yet, every year, thousands of us gather at JSConfs around the world to discuss a Turing-complete programming language that rose to prominence thanks to being the only programming language available in the browser. So if we started off as a document viewer, how did we get to where we are today? Well, the thing I want to talk about next is two clever hacks. And the first hack is the notion of the cookie. When the browser was originated, it was simply a vehicle for delivering documents. It was, by design, HTTP as a protocol was stateless. But then the cookie allowed us to layer state on top. So before, everyone would always see the same document, no matter who they were, but cookies really changed everything. You could now tailor a custom document based on who was making the request. And I think, ironically, by introducing state onto what was previously a stateless protocol, this was the key to letting the browser transform into sort of application, from a pure document viewer into a sort of application runtime. And this, I think, really is what let us begin to give native applications a run for their money. It was what allowed us to build the first very primitive web applications. So the second hack is realizing that instead of the browser being purely a document viewer, you could treat it as a viewport. You could treat it as a viewport to an application running on the server, a so-called thin client. So the data lived on the server, the application logic lived on the server. Even deciding what the user saw, you would render all the HTML on the server. As far as the browser was concerned, you weren't changing it, right? You were still just looking at a document. But this document was generated dynamically on a computer miles and miles away. So remember, at this point, there was no JavaScript. Every time the user interacted with a page by clicking a link or clicking a button, the browser would transmit that command to the server, and the server would update the state of the application for the user and then send back an entirely new HTML page. And that represented the new state of the application on the server. If someone else made a change before you had requested new data, you were none the wiser. The user was none the wiser. Once it was rendered in the browser, that was it. So the analogy I like to use for this model is it's kind of like being at a club with a strobe light going on, right? You can see what's going around you, but you kind of only get bursts of the state at any given time. Everything's really choppy. Your eye can only see the world one slice at a time, instead of being this kind of smooth, continuous spectrum of movement. Or kind of like a zoetrope, if you remember the old animation systems. If those would start to slow down, they would look very, very choppy. Now, the thing that I want to emphasize here, it's important to understand that despite large parts of the global economy being built on this very architecture, at the end of the day, it's a hack. It's a beautiful, wonderful hack, and I'm not using it in the pejorative sense here, but it's still a hack. I'm using the word hack more like in Apollo 13, when the NASA engineers figured out how to MacGyver these square CO2 scrubbers into the round sockets of the lunar module, right? It was this mixture of awe and delight. Oh my God, that's amazing. But maybe we shouldn't attempt this again in the future if we have the option. But there is an unintended side effect that fell out of cajoling the document viewer into an application viewer. And that that side effect, I think, is what ended up being the strength of the web. This is the thing that allowed web apps to win out over their native counterparts. And I'm referring, of course, to the URL. So in order for a browser to act as a viewport onto an application running on the server, you need to tell the server which part of the app the user is looking at the moment. So in order for someone to build a server-rendered web application, the URL is quite literally the first thing you have to understand, the first thing you have to think about. If there's no URL, there's no application. But there's more to URLs than just this principle, right? There's more than just sharing. There's more than the fact that I can just copy and paste a URL to you and you can see the same thing. So basically, by sheer coincidence, and though it was very crude, web applications were really the first collaborative applications that saw widespread use. It was kind of accidentally collaborative because the data was all stored on the server, and you had these URLs that you could share. But you could also bookmark. You could also bookmark these things and save them later. To this day, there are some preference panes in Microsoft Word that I've seen only once and was never able to conjure again. And one thing I think that we miss, too, is that web applications are forkable. If I'm in the middle of a task and I see something in the application that I'm like, I should really pick up on that in a second once I'm done with this thing, I can work on that thing in parallel just by, on my Mac, command-clicking that link, and it opens up in a new tab. That's crazy. This allows you to very efficiently queue up stuff to work on without being distracted from whatever your current goal is. And something that we rely on every day on the web, and to the best of my knowledge, is a feature that I've never seen in a native application. That's huge. So this is all well and good. Server-side rendered web applications have got us very far, and they have shown us the importance of the URL. But server-rendered applications have problems as well. The two most important problems with server-rendered applications, in my opinion, one, they require a round trip to the server every time part of the UI needs to be updated. So if you're offline, you're screwed. If you're on a very high latency connection, you're going to be frustrated. And most importantly, they require the server to rebuild the client state every time a request comes in. So for simple applications, this is, of course, fine. But if you're trying to build sophisticated UIs, it's both complex and it's difficult to cache. And you really want to cache it because they have to round trip it every time. So we needed some kind of programming language that would let us run logic closer to the user. And for better or worse, what we ended up with is JavaScript. So especially at a time when the average internet connection was very high latency, JavaScript gave users immediate feedback with things like form validations, right? You wouldn't have to wait for this round trip to the server. You would just give feedback right away. But at the time, JavaScript was very slow and very limited. You couldn't write entire applications on it. So what we started doing is just slapping JavaScript on top of the server-rendered applications where it made sense. So this is a little bit like bolting a rocket launcher onto a minivan. But at the time, it was really the best that we could do. But as we got a better and better grasp on building web applications, we started butting up against JavaScript's limitations. We saw the benefits of being able to do AJAX replacement on some things. We saw applications like Google Maps, which were just like mind-blowing. You remember the first time you saw Google Maps? You're like, holy crap, I didn't know the browser could do that. So we started demanding more out of JavaScript. And in fits and starts, the browser vendors started to give us what we were asking for. And we've started using more and more JavaScript in our apps, which I think is really great. But now I think we're at a little bit of a crossroads. So the majority of web developers today in 2013 really, really, truly want to cling on to the ancient hack for very good reasons. Particularly, it feels comfortable. We know how to use it. It's familiar. But it's not actually necessary anymore. And then there are other folks who see the JavaScript future. They've embraced it. But they're kind of stepping timidly into the future. They're only writing parts of the application in JavaScript. Even though they might be large parts, they're still having trouble getting rid of that original hack of an architecture. And then there are those who realize that the future is here, and they've started writing 100% JavaScript apps, which is awesome. I think that's great. But the problem is both users and pundits often decry these 100% JavaScript apps. They say they feel broken, or they're heavy, or they're no better than the Flash dystopia that we almost found ourselves in the early 2000s. And I think the reason for this is that in the same way that the phone number is the universal UI of the phone system, so too is the URL the universal UI of the web. So with JavaScript, you're not required to think about URLs first, right? You can write a JavaScript app without a URL, and it will work just fine. But it will feel broken to your users. So if we want to step into the future without breaking interoperability with the past, we have to somehow marry these two ways of building applications in a way that's cohesive and doesn't introduce undue complexity into your app. So I want to ask a question of what is a web app, but the way I'd like to frame this is by contrasting it and asking, what is a native app? Well, if we think about what differentiates someone who's a native developer from someone who's a web developer, usually we think about things like the native development environments have things like sockets that you can open. You can manually manage your memory. You have 3D accelerated graphics. You could do like 3D stuff. You have access to the local file system. You have concurrencies using threads or green threads or fibers or something. And you also have numbers other than floats, which is pretty important for things. But I'm here to be the bearer of bad news. It turns out that all of these things are available in evergreen browsers today. So you have WebSockets, you have typed arrays, which gives you a ton of stuff, and it's basically the thing that underpins what makes ASM.js possible. WebGL, IndexedDB, file reader, web workers, you have all of these tools available to you. So if you think, I program using HTML, CSS, JavaScript, that's what makes me a web developer. No, sorry, that's incorrect. The thing that makes you a web developer is if you build apps that have URLs. Because if you don't do that, it's literally no better than putting an exe on an FTP site for people to download. So how do we build applications that respond and behave like native apps, but don't break the web? Malta said if I gave a talk about a JavaScript MVC framework, he would, quote, kill me in my sleep. So, that's not a verbatim quote. So I'm going to introduce a new terminology that I think is important for building apps that respect the URL. So I don't know how full of shit I am with this, but I'll call this RMVC for now. And the R stands for a router. So if you want to make client-side applications in the vein and the similar architecture to how people are building native apps, which you really want if you want that nice UI that you get on your native apps, you still need to respect the URL. So the router is an object that exists in your application that is the single source of truth about what's on page at any given time. And the router is responsible for configuring the models, the views, and the controllers based on what the current URL is. You can think of it kind of like the serialized form of your application. You basically serialize what's the current state of my application, you put it into the URL. And if any of those things change, if the model that's on screen changes, or the template that's being rendered changes, it's the responsibility of the router to go into the URL and update that. And it turns out that the URLs that we see in our everyday lives map pretty nicely onto the MVC concepts, right? So URLs map nicely to MVC. I don't think that's much of a surprise. So for example, in this first example, /photos, there's an implicit model here, right? It's basically an implicit model saying, show me the photos template, the photos view, and give me all of the photos that you know about. In the second example, we are identifying a model by ID, and it's the responsibility of usually the router to convert that ID 3 into a blob of JSON or whatever. And we actually, I think, just started working on this in earnest, is how do we serialize controller state into the URL? And I think the best place for this is the query string. I think that's what it's designed for. Changes things like sorting. That tends to be what I use controllers for anyway. And you can even do deeply nested things. So you might say, show me the comment with the ID of 42 that belongs to the parent photo with an ID of 3. So we do a lot of this stuff built in Ember, which is what I work on. But I'm not going to talk about that today. Instead, what I want to talk about is the 2 micro libraries that we've extracted from Ember that you can use in your applications, whether you're using Angular, Backbone, whatever. These are basically very, very small, very modular libraries that we've extracted out, and these form the underpinnings of the Ember router, but you can take them and use them in your application however you'd like. So I'll just real briefly give you a tour of the API. Basically, you create a new router. You say var router equals new router. Then we have implemented this DSL on top. So you say router.map, and this will pass you a match function. And the API just looks like this. You can, the syntax supports dynamic segments, so anything where you see :ID here, that's basically a placeholder for the ID of the model that you want to extract. And then you map it to a handler. So these are just unique names that you select. And you'll see on the next slide how these come into play. So in this example, we're saying we want to match a post/ID. We want to match all of the posts if someone comes into that. And we also want to give the user the ability to create a new post. So once you've defined all of the routes in your router, the next step is to give it some handlers. So this is a very, very simple interface. Basically, your router has a method called getHandler that gets called with the name of the route that matches, and then we invoke that handler for you. And there are a couple different phased things here, and I'll get in just a second into that. But basically, this is broken into 2 steps. The first step for that route is we say, give me the model that you want to represent. So here on line 1, it's saying app.post.find params.id. So this is some model library that I'm using. It's just saying deserialize that ID that's in the URL into an actual JavaScript object. And then that that model is going to be passed to the setup function of the setup function of the handler. And at that point, it's your responsibility. You can do whatever you want here. You can render a template, you can update the DOM, whatever. So this is an example of two of these things just a little bit closer together so you can see how they map. So in this case, we say match post/id to show post. So what that means is that when the user comes into /post/1, for example, it's going to invoke the show post handler, and the model hook is going to get a params hash, and you can use that post ID to basically go fetch this JSON from the server. And what's really cool is, if you notice what I'm doing here, the model hook can return a promise. So a lot of libraries, I know there's been a lot of great talks about promises here. Anything that you return that's a promise will wait until that promise resolves to call the setup function, which means that you don't need to worry about whether the data is there or not. You just don't render your template, for example, until that data is resolved. So this integrates through promises very nicely with basically any data management library that returns promises. So there's a lot more in router.js and the other pair library called Route Recognizer. We have really deep promise support, so the whole thing is instrumented for promises. We've been doing a lot of work with promises, and we're very excited about them. We also support things like asynchronous transitions, which end up being very important if you're doing authentication in your JavaScript app. We support deeply nested URLs, basically arbitrarily deeply, and a lot more. So check out the README. I think this is really the secret sauce in Ember, the thing that people really love, and now you guys can use it in your applications today. So check it out. We're on GitHub, github.com/tilde.io/router.js. So a few weeks ago, I wrote a blog post called Progressive Enhancement is Dead. You can see that I definitely do not have a penchant for controversial blog and inflammatory blog post titles. I said, don't be ashamed to build 100% JavaScript applications. And the thing that I want to reiterate is that the browser is not HTML, CSS, and JavaScript. The browser is a box of content with a URL at the top. In the same way that the phone system is no longer some person sitting in a central office, but I still punch phone numbers into my phone, it's going to be the same with the URL for the next 20 or 30 years. You can imagine HTML, CSS. These all get replaced with WebGL or some fancy widgeting library. The point is, the URL and the box of content below it is what you are building. I was actually really dismayed recently by, I was using a Chrome packaged app, which basically runs an HTML, CSS, JavaScript app in your browser, but it removes the URL. I was literally using an app in my browser, and I saw an option to open it in my browser. What the fuck is going on here? Anyway, so I want to amend my original statement. Don't be ashamed to build 100% JavaScript applications, but if you do, make sure that you do so with an understanding and respect for what gives the web its strength. Thank you.
Awesome. Thank you, Tom. Anyone have any questions? Food trucks in Portland, I'm sure we could cover that, maybe. Oh, yes.
Well, thanks for the presentation. I see the main problem with this approach is the URLs with the crawlability of search engines. Like, we're doing 100% JavaScript applications, but to serve the search engines, we're rendering things with Phantom on the server.
Yes.
And that's the kind of approaches. Are there any developments you're aware of within search engine developers? Or?
Yeah, so that's a great question. So the question is, how do you deal with search engine crawlability using 100% JavaScript applications? And I have a couple answers to that, so I'll try to keep it short. The first is, per a Google engineer who I talked to, who will remain nameless, it is, quote, fucking bullshit that Google has not started indexing JavaScript applications so far, which I agree with, but sadly is outside my control. The second thing is that in Ember, anyway, we use handlebars templates. And it's pretty easy to plug handlebars templates into your backend server and render them. So Discourse is a good example of this. If you guys are not familiar, Discourse is an open source GPL forum software built using Ember and Ruby on Rails. And they just do a very small rendering of the content and put it inside of a NoScript tag, which is actually awesome for two reasons. One, it's crawlable by search engines. Two, it's usable by people if they turn off JavaScript in their browser. So I think we'll get some really good solutions to this in the next couple of years, but right now there are some hacks that you can do to get around this problem.
All right, cool. Looks like we're out of time, but thank you so much. You can find Tom later on the boat or also on Tinder. So feel free to ask him any questions you want. Thank you, Tom Dale.